We have a normal distribution mean of 65.2 standard deviation. Oh no, that's the first one. Sorry, here. Mean of 20, standard deviation of 3. Okay. So, I mean, I still like to draw this out because in your formula, they give you the percentages as the z-score. So maybe that's something you might want to note down, like what the z-scores actually are as you're drawing it out. So I'll draw this out for you really quickly. We're just adding 3 each time. So this one's a bit easier with the numbers, isn't it? So 17, 14, 11, okay? So between 17 and 23 is this area here. And Lawan, what did you get for that one?
68%.
How'd you do that?
Basically, it's in the formula sheet.
It's on the formula sheet. Oh, that's, how convenient is that? So part 1, that's 68%.
I am actually smart like that.
So between 17 and 23, 68%. All right, next one for me. Who was next on the list? Maggie. So we are doing, why is it not, there we go. 14 and 26. So where's that looking like? So 14 and 26, what's that going to be?
2 standard deviations.
2 standard deviations, right? Yeah. 95%, yep. So remember, 68, 95, 99.7. All right, perfect. So that's just 95%. Who is next? Part 3, 11 and 29. You guys are getting all the easy ones. Harry. 99.7, there you go. 99.7%. Part 4. Blake, what's part 4 asking for? It is. Why do I have... Oh. What the heck? Do I actually have 7 parts? Did I miss 17 and 23? As in, should that be part 1? Oh, I see. My mistake. I just wrote something wrong. I don't know what it was. All right, part 4 is not, sorry, 11 and 20 is what I'm looking at. So part 4 is 11 and 20. So Blake, what are you thinking for this one? Shh. Just going back, guys. Half of 99.7%, well done. So because we know it's symmetrical, so we can just halve this whole section, right? So that's half times 99.7%, and that was 49.85 from memory. And part 5, Kyle, what do you got for me? What's part 5? Let's see, I've got to write this down. 14 and 23. So 14 and 23 should be this section here. And how'd you get that?
95 minus 68 divide the whole thing by 3 and then plus 68.
Whoa. Okay, so slow down again. So, yeah, take it easy there. So you want to do 95%, which would be this whole section here across.
Yeah.
All right, and then what else did you want to do after that?
Minus 68.
Yep.
Divide by 2, which gives me half of those things.
Yeah.
And plus back 68. But
Okay.
I feel like that could be simplified.
Yeah, okay. So you want to find, so what did you use to do the 95% again? Remind me? What did you do with this?
So I can get rid of the missing bit.
Yeah, so this whole thing is 95, and then you took it away from 68%? Is that what you did? No.
Took 68 away
From the 95,
Yeah.
right? And that gives you these extra bits here?
Yeah.
Yep.
And then divide that.
And divide by 2, yeah, right, okay. That's the way I was thinking. I don't know if anyone found an easier way. But the idea is that, okay, if you want a section that's not quite even, right, I have, from -2 to 1, I can't just use the empirical rule anymore. I can't just say it's 68% because 68% is only for that section. There's this little bit here. So what Kyle is saying, okay, let's find this extra section. In fact, we can't find it even straight up. What we can find is this green section. Right, the green section, as Kyle said, is going to be 95%, take away 68%. Because if you think about the 2 sections over here, right, if this is 95% and this is 68%. When you subtract them, you're going to get the extra bits out of there. Does that kind of make sense, right? You're getting the extra bits out of there. So then 95 minus 68. What's that? 227? 27%? Is that right? Oh, I was just doing this bit first. Is that 20? Yeah. Or did you put it all in your calculator at once? Okay, that's all right. That's okay. That's 27%, and we want half of that. So half times 27%. I'm guessing it's like 13.5, right? And then you say, okay, now that I know what that one section is, that's 13.5%. We take we don't want this anymore because the original question was actually asking for this guy, right? Gonna get rid of that. Original question was asking for 14 to 23. So we do 68% plus 13.5%. 81.5%. Yeah. Any of these ways? Yeah. 95 on 2?
So you've got half the area of the 95 one, and then half the area of the 68 one.
Yeah. Do we have the half the area of the 68 one?
Yeah.
68 is from here to here?
Yeah, so you got half of that.
Okay, so we want half of that. Plus.
So you've got 0 to 1,
Yeah.
and you've got the negative 2 to 0, which is half of 95.
Oh, of course. Yeah. Okay, there you go. All right, see, like I said, everyone thinks in different ways. I didn't even see that. So what Maddie's saying is an easier way.
Sort of like the area from negative 2 to 0.
Yep.
Which is half of 95%.
So I've got this section here, right?
So there's that, which is half of 95%.
So that's half times 95%, which was,
Or just 95 over 2.
what is that?
Just do 95 over 2 plus 68.
How is this root as well?
Yeah, we'll say 95% on 2. I like the number though. What is it? 47? 47.5.
It makes it look so much more complicated.
Oh, is it? Okay, I can leave it like that. I'll leave it like
Just
that.
do 95 on 2. And then next to it, right, plus 68 on 2.
Okay. 95% on 2, right?
Yep.
And then I also have this, let's say, green bit here. And that green bit is, what was it, 68% on 2. Is that what you said? Yeah, okay, cool. And then we add them together. Yeah, perfect. So that's, and when you add them together, we get 81.5?
Yeah.
Perfect.
Nancy, how do you know?
I can't take credit. That was all Maddie, actually.
No, that was you.
Perfect. And last one. What's the last one? Oh, Harry, you said you would, wait, who was doing this one? Oh, Jordan. What was it, 20 and 26? Wait, isn't that one easier? Yeah, I think the hardest one was actually that one just then. So what was that, 20 and 26, how'd you do that one, Jordan?
95 divided by
Yeah. Yeah, so we've got all these standard deviations. It's all a big mess here, but we've got from negative 2 to 2, we know is 95%, and we've got half of that. So half of 95%. Or 95% divided by 2. And that was, what was that? 47.5%. Perfect. All right, awesome. Any questions about that one? So like I said, right, I guess it's less about overcomplicating, being like, hey, what do you think of first? If you think of the way that uses more operations, but you're going to get the correct answer, then that's probably fine, right? It doesn't really make a difference if you do it that way. No. Cool, that's the empirical rule.